This page is titled 5.1 Notes. It's at the very top. So my plan for today is I was going to do 5.1, get a start of it, or you should be able to get done. And then tomorrow is the every other Friday. So tomorrow I'm going to talk about how credit cards are not the best of things, but then I'm going to give you ideas and share ideas of how credit cards are helpful. But I'm going to show you how credit cards are actually very harmful, because you'll see tomorrow. Bless you. So, and I think that'll be a nice application of how math works, which is great. It doesn't apply to the derivatives and stuff like that, but that's fine. Okay, so 5.1, increasing, decreasing, maxes and mins and horizontal points of inflection. That would be a mouthful. All right, so I'm going to try and regenerate this graph that they have drawn. I hope to do an okay job of it. Oops, I can't actually hear it. All right. Does that look kind of sort of close? And so they have a point A here, point B here, a point C, a point D, a point E, F, and G. Okay, so I don't know what the equation of this graph would be. Okay, and that's not really important. So a lot of times the picture of a graph gives you some indication. So we want to see where it's, first thing I'm going to talk about where it's increasing, we'll do in red. Okay, so what it means when I say increasing, on the problems that we had worked on before where we took the derivative and then I said, hey, find the equation of the line tangent. Okay, you know what I'm talking about? First three problems over on the quiz. Still with me? That means that if the slope of that tangent line was positive, that means it's increasing. So we have increasing here. So we're going to go basically this red region here. That's going to show us increasing. We also have increasing here, and then it flattens out. So I'm going to stop kind of that. I'm going to stop short, though it will probably be increasing and decreasing a little bit more, but I just want to show that that does start. So these are some places where things are increasing or decreasing. So if I had to put a letter, where it would be increasing or decreasing, or increasing, it would be at C, and it would be at point E. Okay, so if I were to take the derivative of this function and I were to find a point of tangency and then find the equation of that tangent line at the point of tangency, which we've been doing, the slope of that line would have been a positive slope. Okay, so that just means where it's increasing or decreasing. Okay, or increasing. If I go decreasing, well, if increasing means the slope's positive, then decreasing means the slope is silence. What do you think? Increasing is positive, decreasing is negative. Thank you. All right, so a decreasing slope would be taking place in this region here. This is decreasing. Okay, it's also decreasing here. Okay, so if I had to put a letter with where it's decreasing, point A would have a slope that's negative. If I were to take the derivative, and that slope of that point of tangency would be negative. And then letter G would also work. Even though it happens to be an endpoint, it still would work. Okay? So increasing means the slope of our line that's tangent would be positive. It's going from lower left to upper right. If it's decreasing, it's going from upper left to lower right. Okay, so increasing slopes would mean like the tangent lines look something like this. These are all slopes that would be positive. These would be slopes that would look negative. They drop to the right. Increasing increases to the right. They drop to the right on decreasing. Okay, so that shouldn't be too tough to kind of think about when you're looking at your graph. But then you have maxes and mins. So we'll do a max in green. Okay, a max is a turning point on our graph where we go from an increasing slope to a decreasing, or decreasing and increasing. So the slope, it's the point where the slope goes from a positive to a negative, or a negative to a positive. Okay? So it's a maximum where we go, so we either go like this. So let's think about this for a second. I need to erase something. I just put something wrong. So the max, so if you think about with this line, if I had a bunch of tangent lines, I have a positive slope like this, and then I have a horizontal slope, and then starts going down. The max happens right here. So the max on this one would be point F. That's a max. All right, let's choose a color I haven't used. Let's go with something fun. Ooh, that's a good color. I like that. All right, so let's talk about a min. Min, again, talks about slopes. And a min's going to be where our slope would go from negative to positive. And how that's going to work is I have these negative tangent lines that look like this. Okay? So that would be a minimum. So our minimum point for that would be letter B. And then a whole new idea. Horizontal points of inflections. So a point of inflection. Okay? So the point of inflection has a slope that is equal to 0. Okay? There's a number of things a point of inflection does, and on the next, I'll bring up another slide. It'll help you a little bit more. The point of inflection is point D on this. Okay? The point of inflection takes place where you could have a positive slope, positive slope, slope of 0, and then positive slope, positive. It didn't become a max or min, or it could be a negative slope all the way through. So an idea of a point of inflection is a graph that looks like this. Okay? So there's something here that's taking place. And what it means when I'm doing my tangent lines, let's see, let's do them in orange. Can I do those? Do that in orange. So these are all tangent lines. There gets to be a point at that dot where my tangent line flips to the other side of the line. Okay? So if I were to look at the slope of all of these, all the slopes here are positive, positive, positive. The slope exactly here is 0. Then it's positive, positive, positive. It didn't follow the rules of the max versus min, where I didn't go to a positive to a negative or a negative to a positive. Science class is acting like they're actually doing a real experiment with steps. Is everyone still here? Because the door's locked, so someone's like, all right. So that's a point of inflection that way. You can also have a point of inflection that looks this way. It looks like your curve is kind of flattening out. And if I were to do my tangent lines to this, it would be the same way. So I'd have negative slope, negative slope. Let's say they're touching. There's something that's going to take place right there, and then it's going to flip over to the other side of the line. So point of inflection just means something's taking place. Kind of an idea you can think about is let's do a curve with a highlight. So let's say we have this. So things that take place, I'm going to draw a bunch of tangent lines. And it's kind of hard to see, but each one of those black lines against the pink are touching the pink one time. It's kissing it. Okay? Something's going to take place right here to make the tangent line go to the other side of the pink line. Okay? That big red line right there in the middle is the point of tangency where our slope would be 0. It's a point of inflection because my slope doesn't change signs. It goes from being positive to 0 to positive. It could be the same thing with 0 if it was negative, point of inflection to negative. Same idea. That's what tangent lines are doing. That's what we were finding when we were doing the derivative, when I gave you a point saying, hey, we have y equals x squared, and we know that x equals 3. Then we plug 3 into x squared and get 3 comma 9. That's where the point of tangency would take place. You take the derivative of x squared, you get 2x. You take your x value, plug it in, it gives you the slope at the exact point. So these all relate back to, when we used our point slope equation. Okay? So each of these black lines would have a different equation. The slope's changing, the point of tangency, the x comma y, are changing as well as we ride along it. Okay? All right. So let's think for a second. What does a derivative find in its simplest term? What does a derivative find? So if we did y equals x squared, and I took the derivative, I'd get 2x. Okay? What does this derivative really find? Well, let's pull up Desmos and see what happens with it. Let's see. Dump that. Go here. Desmos. Graph. So I have y equals x squared, and I have y equals 2x. Okay? So, things the derivative are doing, you are changing the power from a higher power to one lower, and you're also figuring out a certain equation. So, what can you tell me about that blue line? What kind of slope would you have on that blue line? I know it's not a point of tangency, but what's our slope? Is it positive or negative? Okay. So I think we can go back and take a look at our F prime chart. And this is about probably be as far as I'll go today, okay? Because this is like a brand new idea. I don't want to, I don't want to hurt anyone's feelings. But this is, a tougher thing to think about. So it lets you, give you some time to process it. So I'm going back to my very first graph. Okay. So we have A, we have B, we have C, we have D, E, F, and G. So then I'm going to do an F prime chart. Okay, they use capital F. They call this F prime. That means we're doing the derivative. So what an F prime chart does is it mimics our graph in one dimension. Okay? So, we do have critical values. We do have critical values which take place here, here, and here. Those are all critical values because they touch the x-axis. So the red are called critical values, which means it's where it's crossing or touching the x-axis. Okay? So I'm going to have this, I'm going to draw kind of straight down. Right here I have a critical value. I don't know what the value is, but I'm just going to put it. There are times that you definitely will know what the critical value is. This is point G, which is also a critical value. I don't know what those other 2 points are because we don't have them labeled on that. All right, so critical value, cross the x-axis. Another word for critical value is a solution. It'd be a point you could plug in, which would give you, you'd put a number in, your y value would be a 0 when you plug it into your equation. All right, so my sign chart, let's go from here to our critical value first. So I now made the line blackish. What do you think the slope would be of that line? Positive or negative? Negative. So on this side of the critical value, I'm going to put a negative. Critical value means it's a 0. You don't necessarily have to put it 0. It's fine if you do list it. Okay? And then after my critical value, what's taking place here? What is my slope from here down? Negative as well. And I'm going to label point B here. So we have a negative as well. Point B is what? A min or a max? Min. Okay. Now I'm going to change color, not to confuse it. I'm just change color. What can you tell me about the slope right here up to our critical value? Positive or negative? Positive. Do you all see that a sign change took place? We went negative to positive. So that means between the negative to positive, that means that we have a minimum value. So if we go from negative to positive, we have a minimum. Okay, that's the first thing to know. Then we're going to continue after our C value, and it's going to be positive slope all the way up to point D. Okay, so it's positive in between the critical value and point D. Okay, point D, we will know it is a point of inflection. Because if I continue on this path, I flip to the other side of the line, but all the way up here, we're going to keep a positive slope. Okay? So the slopes are changing. The point of inflection means our tangent line would go from one side of the line, it would be maybe slightly above it, to below it. That's what our point of inflection is going to do. So we know we have a point of inflection when the slopes take place. We have a slope right here of 0. Okay? The minimum would also have a slope of 0. But the reason why the slope of 0 at a minimum is a minimum and not a point of inflection is because my sign changed from positive or negative to positive. Okay? So now we get to point F. We're great. So we're going to call point F. Let's change that color. Let's change it to purple. Point F. Point F is a minimum or a maximum just by looking at it. Max. Okay. The slope at a max is also 0. So what can you tell me about the slope of my line as I come after F? Negative. Okay? Oops, let's go over here. Okay, B and I went from positive to negative. That means we have a maximum value. Okay? Now, can I stop there and we come back to this on Monday? Is that okay? What time we out here? 10:06. Okay, we got a little bit of time. Okay, I mean this is a really rich thing. Is there anything I talked about that I can answer questions about? I was trying to go slow enough to allow you to check your tweets and Snapchats and then pay attention as well. Haha. But this is a much different idea than a lot of you have ever seen, and it's not just because it's new doesn't mean it's difficult, but it's difficult if you aren't staying with me on it. So I'm not here to confuse you on it. Just the thing about when they get to calculus, they love these f prime lines. There's actually, we talked about first derivative. You can actually take second derivative. You can find the third derivative. These all find different things. So there could be an f double prime for a double second derivative. But what this down here should mimic is what the slope would be doing on our graph that's given. Now the scary thing is we're going to go from here to say, hey, what should the picture kind of look like, to here. So we will go backwards as well. But I don't want to dive in too deep on that for you. I want to take the last couple minutes. So Friday we're going to talk about how credit cards work. Okay? 2 Fridays from tomorrow, I was going to talk about how a mutual fund works. And the reason I'm going to talk about a mutual fund is I'm very aware of mutual funds and investing. Now, here's the hard thing as far as investing goes. There is always something that you could invest in that's going to skyrocket. Okay? Bless you. I actually bought and it was just on a whim. I was about your age, and this is in 1988, and my friend's dad was in the market, and he said, hey, Chris, that's my name. I said, yeah. You got $100? $100 in 1988 is kind of a long time ago. I said, in the bank. I got a stock. Okay. You should invest in it. Okay. It's $100 though. Now, $100 back in 1988 is basically probably $800 to you right now. Okay. Just trust me. This guy, my friend's dad, his name's Sam. Sam had coached me in soccer, baseball, football, all through my being a little kid. He was the one dad. He was my friend Matt's dad, but he was the one dad that was always home. He was able to work from home. Like he would leave for a week and then have like 19 weeks in a row that he was at home. So he was always home. And he actually brought a bunch of us together and asked all of us for $100. Now, all of our parents thought he was absolutely insane. And my dad, I remember saying to me, don't do it. Well, y'all have parents like me. When your parents say don't do, you better do it, right? So I gave Sam Owens $100. Sam Owens bought a stock that was $2.50 a share. Okay. So 250 goes 2.5, or 250 goes into 100 how many times? 40. Okay. Will somebody let me know what Apple is trading at right now? 173. How much?
It's like 173.
200?
It's like 173. 20 minutes ago. I didn't look at it.
Apple 173?
174. There you go.
Am I happy that I went against my parents' wishes?
Hold on. You got one with the stock splits. Like
it did. It split and doubled a few times. So I will tell you that the original $100 is worth a little bit more than $100. It's like $100.06 or something like that. Now, I got to tell you, that was the only time Sam Owens ever said anything to us, ever, about investing. I don't know how he had the inside scoop on it.
Quick question. Why would your parents say no? It's like the late 80s, correct? Apple's like well established at this point. Right?
Not really.
It's definitely the Mac in the early 80s, like the first Mac, right?
So our first Macintosh computer we got in 89, 90, somewhere in there. That's what we got. Now there was others that were out there, but yeah, what would have been great if Sam Owens came to me in 1982 when I was 12 years old and said, "Hey, give me $100," because at that point Apple was trading at about 16 cents a share. Yeah, if Sam Owens had done that for me back in 82, I might be sitting on some island right now, figuring out how I'm going to surf the waves that are out there. It's good stuff. So now you all know the one guy who got in and did something. Yeah, splits and doubles, they're crazy. So, are there others that will do that? Do you know Sam Owens? I don't think you do. He's a good guy. He was a good guy not because of the sock tip. He was always a good guy. So there are definitely things, but I'm not going to talk to you about individual stocks, but that's just one good thing that happened. Say